Hello, my name is Angelica Coriano. I am going to be presenting today a demonstration of my final project for Microcontrollers Spring 2026. The project overview of what I had, just to go through my PowerPoint, is a timer project clock. Essentially, what would be happening is I'm using an interrupt to update an LCD with the time every 100 milliseconds and use the same interrupt to trigger pulse width modulation to control an LED in the first 600 milliseconds of a second. These are the functions that I'm using from chapter 8, 1 through 8, and 10. To go quickly over how the project works, as I mentioned in the description, I have an interrupt using a pit timer. That is what is creating the ISR. It is set to 1 millisecond. So for the bus clock of 24 megahertz, or divided by 1 millisecond, the load value is 24,000. As those interrupts are generated, you have I'm going to show right here, we have several counters updating. The counters are the only thing that we have in the ISR. As I was doing this project, trying to put any LCD update or pulse width modulation update in the interrupt into the IRQ handler caused major bugs and crashing. So everything was moved out of the handler and only the counters were left there for updates and flags. As you can see here, we have a LCD update flag. And then the main is what calls for those updates. As of right now, as the project stands, the timer is working, but the LED is not. Over the last week, I've been trying to fix the LED, trying to figure out why pulse width wasn't working, including using the onboard RGB. But right now, because of the way the LCD is set up, it is currently using the port that controls the blue LED, which is overtaking everything else. So then I moved to an external LED. And I ran through, did the setup, double check the ports, but I was never getting any voltage. At one point with a code iteration that I had, I do in this current version have the debug set to 300 seconds, meaning instead of my pulse width modulation happening from 0 to 600, I have it from 0 to 300 milliseconds, so 3 seconds in case it was a problem of going too fast, as I had assumed it was with the blue LED before finding out it's just updating with the LCD. I'll show the screen a little bit better here. Today, finally, after doing a couple updates, I put a multimeter to the LED, and I found that the voltage wasn't changing beyond 0.3 volts, so that it wasn't outputting. And since the project is due today, I had to leave it at that. I did keep trying to do iterations. I ended up changing how the pulse width modulation was controlling the LED. This doesn't work as well as what I had. But hindsight is always 20/20. I didn't save it, so it doesn't show. But while I was testing it earlier in the week, I'd have the pulse width flag actually decreasing from 3,000 to 0, even though the LED wasn't turning on. But I didn't save it while still trying to make changes. But the timer is working. It's been running for 32 minutes as I have been doing my updates here. If I go to here, it's just connected to power. I forgot to mention, the timer is controlled by the pit. As it takes up a millisecond, so do the seconds counter, which updates the seconds, the minutes, and the hours. And it does also updates the millisecond counter, since it's formatted a little bit differently. That way every update is on the 100 millisecond. So you see the 1, 2, 3, 4, 5 up to 900 milliseconds to 10, and then it updates the second. So I had done a couple iterations and tries throughout the week to try to get the LED to work. With more time and line by line and with everything, I believe I could get it to work. But as of right now, it just is the one thing in the project that I couldn't get, even with trying to extend the timeout for it, trying to make changes, trying to change the channel, trying to change the ports, updating the pulse width modulation module that it uses. it was still giving me problems, and it got to this point, 4 p.m., which is an hour and a half before it's due, and I just had to do the final update with what went right and what went wrong. And that is my final project for microcontrollers.